Now, if we're thinking about money, the more times in a year you compound something, the more times you make interest on interest. And theoretically, if you would change that to a function that was always compounding, more than every second, then the variable e appears, and this formula changes from p times 1 plus r over n to the nt to, we call it the PERT formula because that's sort of what it says when you read it. Okay? A is still the final amount, p is still the principal, r is still the rate as a decimal place, and time is in years. So now it's interesting, just before you figure this out, the question is, how much more do you think it's going to be? From compounding quarterly, we're going to do this one first, which means that interest is only paid 4 times a year, and you only make interest on interest 4 times a year, compared to compounding continuously, that you're always getting paid interest and you're always making money on the new amount of money that you've been given. You're starting with $2,000. 10 years later, we're going to compare these two. How much more do you think the continuous one's going to be? Okay, so we've got some ideas. We're going to figure out the quarterly one first, which would be, the amount would be 2,001 plus the interest rate is 5.5% compounded quarterly, and we're dealing with 10 years. $2,001 plus 0.055 divided by 4 to the power of 40. You get $3,453.54. And now we're going to look at the same thing if it was compounded continuously. And get prepared to be disappointed. In your mental estimation, did you think the difference would be around $13? Did you think it would be a lot more? Yeah. Now, it isn't a lot more. It is a little bit more, but this is 10 years, and it's 4 times a year versus all the time. So why does this happen? Well, if you think about this formula, the more times that you're compounding per year, you see the 0.055 is divided by 4. If it was divided by 1,000, the amount of interest you would get each time would be so small that even though you get some of it and you'd be making interest on some of it, it's so small to begin with that it doesn't amount to much. And eventually it becomes so small, like if you did it 1,000,000 times in a year, you're basically getting 0 each time. It does amount to something, and we see that over 10 years comes to $13, but it's not a lot. The big thing that's going to affect you, like when you guys go to buy a car or buy a house, don't be afraid of one person saying, well, we compound 12 times a year and they compound 365, so you should go with us. Be more concerned, the biggest thing is the interest rate. Even if you can save 0.25% on that interest rate, that'll make a lot of difference over time. So, and we'll look at questions like that in tomorrow's class. What happens when that interest rate changes? So that's going to be the key thing. You can save hundreds and hundreds and thousands of dollars on the interest rate, not so much on how often it's being compounded. Of course, the banks would never advertise that they're compounding continuously, because then you would change banks because you're like, why are they charging me interest all the time? I don't like that. So now with this question, it's compounded continuously. This would be a key word that you're looking for. In previous years when they had the formula sheet, that would be what you would look for to know that you need to use the PERT formula. Now they would give you the formula in the equation, so it's not as big of a deal. But when we plug this in, we know that it's worth $235. We know we started with 200. The interest rate, we don't know. And the time is 3 years. So again, we can divide both sides by 200 to start with if we like. And in this case, using the natural log, it will work if you use log or natural log, but using the natural log on both sides will be even nicer because we're dealing with e in the equation. So if I take the natural log of both sides, and then I can bring my exponent out in front, what is the natural log of e equal to? E to what power is e? 1. Because e to the power of what is equal to e has to be 1. And so then, if we know that that's equal to 1, to get r by itself, we would just have to divide by 3. And we get our interest rate is 0.05, approximately 5%. So try the next one on your own. Set up the equation. We want it to be worth 2,100. We started with 1,300. It's continuous growth, 5.3%, and we're solving for time. Dividing both sides by 1,300 and simplifying, that'll give me 21 over 13 e to the 0.5053t. Again, I'll take the natural log because I have a base of e. And of course, the natural log of e is equal to 1. And did you get 9.05 years as our approximation?